Solar PV is probably one of the fast growing industries I ever seen in my life. And what it means is that technology is being developed so quickly. There is a lag in between what's available in the market and
We are live, ladies and gentlemen. Welcome to another episode of the Soliverse podcast. Today I'm joined here by Maksim Markevich from Sunbim. Maksim, welcome to the show.
Thank you, Peter. Happy to be here. Thanks for the invitation.
Yeah, it took a while for us to arrange this, but I'm happy to finally made it happen. I'm actually joining you guys from Corsica, so my internet might not be the best, but we'll make it work and we will make up for it. But Maksim, starting the story behind Sunbim and PVFarm, where did it all start? Why did you guys create it?
Probably let's start from the beginning. Graduated from university in nuclear power station construction.
Wow.
Engineer by training. I was working as a structural engineer. Mostly I was designing reinforced concrete structures and steel structures for pump stations, power stations, nuclear power stations. And that's the starting point. During my uni years, I did a lot of automation. So every time we made a specific like a coursework or something like that, I tried to code a little bit to make some things easier. And so when I went to work for engineering consultancy, I actually started to make many like small plugins. So firstly, that was a plugins that were connecting Excel, MathCAD, AutoCAD. Later on, that they become a plugins that basically work for AutoCAD independently or Autodesk Revit independently. And then basically those plugins became popular within the company. So I started doing a lot of like consultancy on how to even
What
like
year was this in?
That was 2013, 2014. Yeah.
So that's super early.
Yeah, that's super early, but that's how it started basically, right? So I started to make those small kind of tools that help people to do their engineering work. Mostly those tools, they were based on AutoCAD or Revit API. And then at some point I started to actually dedicate more time to doing this rather than actually designing stuff. And I realized that I enjoy this more than anything else. And also I started to do lectures for internal employees. So I was training them how to use those tools, how to be more efficient, how to use programs more efficiently. For example, let's say you have Autodesk Revit and then structural engineer and architect work together, how to build this flow where they can work together effectively. Even I made a bunch of video courses and YouTube courses. So I have a YouTube channel. I had a YouTube channel, which was popular in the, I would say, in the country where I'm from, Belarus, and the neighborhood like Russia, Ukraine, all of that. So it was a fun. So basically, the more I work on this, the more I shifted from traditional engineering to some kind of software development. And then 2016, at the end of 2016, I met CEO of Creo software company, Magomed, and he invited me to actually to build products with him. And finally, it was more like independent web-based products. So I needed to learn a lot. I needed to learn a lot about different markets. And also those products were meant to be for the United Kingdom market. That's where the Creo software was actually based. And I hesitated a lot because we had a great conversations. And finally, I convinced to join. And so I started in Creo Software Limited. And then we were running it together with Magomed for like from 2017 February to I think 2023 February. So basically for 5 years.
Is this also your entry point to solar?
That's basically in Creo software. We were building two types of products. The first one, it's a building design automation software products. Let's say it's a products like our first one was Creo design or Creo modular. This is kind of conceptual architectural phase where we try to automate the initial phase of designing buildings. And also we were building like a products for quantification and cost estimation. So our tools that currently Creo still exist. It's a quantity takeoff software for cost estimators and quantity surveyors. So we were building those tools. And we actually started with, some of them were more sophisticated, some of them simpler. We failed with a bunch of those. So we basically launched them in the market and they weren't successful. So we needed to shut them down. Then we started the new ones. So we built a lot of cool technology in there. And that's, Magomed brought a lot of amazing like brainstorming sessions and freedom. So there were a couple of years in this company where we didn't care about market and business and anything at all. We were just building technology. I think that was the most kind of meaningful years in terms of like learning and understanding stuff. So it was really important. And then one of our initiative was to start building. So we had this idea. What if we will, because like the first tools we ran, they were failed because we didn't understand good enough the market dynamic and how people work in the market. So we decided to actually start building some bespoke customizations in order to learn basically market a little bit. Let's say you build a specific parking configurator for a specific contractor in the United States. And so you learn a lot about how things work, how they work, how the market works, how like people communicate in general. And then you can build a specific mass timber configurator for Europe. So we were building like many of these building design configurators. And by doing that, we actually were learning a lot about market. And so at some point, I met a partner, and we started talking about solar. That's my current co-founder in PVFarm, Ben. And we started to talk a lot about solar. And I had this dream of my building like a vertically integrated software solution. And solar, such an amazing. I would say solar PV project is such an amazing test case because they actually been built quite quickly. If you think about like building solar farm typically takes like 1 year, like a huge one, 200, 300 megawatt will take you to build like 1 year or maybe even less, 6 months. So which means that comparatively to hospital, for example, hospital can be built like in 6 years. So the shorter the time the project is being built, the more chances you have to build a vertically integrated tool because you can actually fast understand the progress. And imagine if you think about SaaS software development cycle, which is around probably 1 year, let's say, you can build like pretty much any proof of concept or medium in like a minimum viable product in like less than 1 year. And then construction project, if it's a hospital, 6 years. So it's really difficult to build a tool. And so solar was a perfect, and also I think it had an amazing set of problems which we could solve mathematically. And so we started working with Ben on this, and we started building PVFarm. Then later on, the PVFarm technology was bought by the partner. We started working when I was in Creo, and there was a chance for me to establish a Sunbim and to take my engineering team that was working on solar, and that's a company called Sunbim based in London. And then PVFarm is our joint venture in between the partner and Sunbim company, and it's based in the United States. So that's how we started PVFarm, basically.
Okay, and maybe just to recap, because you covered a lot of ground, I want to make sure that both me and the audience understands this. So basically, you started from automation in architecture, right? And then you shifted with that software-based background into solar, right?
When I started with automation is in structural engineering in the first place.
Okay.
Then it was architecture and many other fields related to, let's say, residential buildings or hospitals or, like different types of building, reinforced concrete frames, mass timber frames. So it did a lot of automation in the field of multifamily and parkings and stuff like that. And then, started learning about renewables and solar PV.
Okay. Yeah. So we got it right. It makes sense.
Yeah.
So now we arrived at the solar problem that we have a construction that's needed to be built quickly, that needs to be designed quickly as well, and of course it needs to be iterated quickly as well. So what is the problem that you guys solve there, both with Sunbeam and maybe after that PVFarm?
Yeah. So that's a good question. And imagine like you learn in a new industry. You never been part of it. So the first ask from my side was to actually to shadow. It's called the process called shadowing. You literally follow the people during design process, you kind of been invited in the meetings where you simply sit and listen to what's happening. You can see how performance modeling engineer communicates with electrical engineer, an electrical engineer with civil engineer and structural engineer and design manager on top of all of that. And you kind of see this happening. And you also can see what does it mean to basically construction drawing set, how does it look? Then you see what kind of deliverables they have at early phase. What does it mean to have design 10%, 30%, 60%, 90%, etc. So first you basically observing all of that and absorbing the type of things you see. And then the biggest problem we actually saw in all of that is that efficient layout, solar PV layout, is a combination of multiple disciplines working effectively with each other. So whenever someone like driving layout efficiency alone, it's a kind of siloed and one directional optimized layout. So that was never a good thing. So we started with a collaboration problem, which is collaboration is a big problem in general in AEC, but we actually started with this one in solar PV farm. So that was the biggest problem. We wanted those independent silos to speak to each other and to test ideas together. So that was initial concept. That was the first problem. The second problem, solar PV is probably one of the fast growing industries I ever seen in my life. So, and what it means is that technology is being developed so quickly. There is a lag in between what's available in the market and how people learn how to use it. Let's say new modules, new wiring architectures, new inverters. That's why the second problem was education. Because when you have a fast growing industry, you need to attract talent as quick as possible, but also you need to explain to this talent what the heck it means, right? So what's their job and all of that. So the second problem was the actual education. And we, as a solution to this problem, we wanted to build like a playground where people can test huge variety of different ideas. So that was, I would say, two main problems where we started. And then we moved to many other different problems, which mostly were like a strategical, logical development of those previously known. For example, if you think about collaboration, the only way people can collaborate effectively in the solution during designing process only if they have independent tools which are flexible and good enough to do their job. So if you think about civil engineer, the only way that person can collaborate in our platform if we will have enough functionality for this person to do their job. So then we started to develop like kind of disciplines within PV farm, like layout modeling, electrical engineering, civil engineering. And then we started to basically to merge those together and to see how this all work together. So that's kind of the
So
yeah.
let me make sure that we understand, both me and the audience. So basically, you have identified the silos, structural engineering, project management, etc., and then you try to integrate and translate those jobs and problems into the software. Is that correct?
That's pretty correct. Yes.
Okay. Okay. Excellent. So please continue.
Yeah. So and also there was one important concept which both me and Ben loving is that we wanted to build PV farm tool starting from a construction, or not, I wouldn't say like starting from an exact construction, but as close as possible to the construction. So basically pre-construction, procurement, late stage of design. So we wanted to understand the constraints of the real physical world and then basically building software backwards. Because in my experience, I actually had built many products starting from feasibility phase. And there is a point in time when it is extremely difficult to move closer to being valuable during pre-construction phase because it's just difficult. So this is the way that's extremely difficult to grow system. So we started closer to the construction, knowing the limitations of construction, logistics, staging, and all of that. And then we tried to use those principles while building the design automation for solar PV.
But
That's I would say, the unique aspect of this product
and,
as well.
and when you focused on construction, were you shadowing, as you mentioned, only one company, or were you testing your ideas with multiple companies as well? Because I see that could be a challenge.
We went actually on the construction site. We visited many construction sites later on, but back then it was more like a pre-construction, how people preparing stuff for construction. We were shadowing, like the way we built PVFarm. The first year we were just building like the basement, and the second year we invited partners. So we invited around 10 other different companies to basically work with us on basically refining the problem set, solution set, and all of that. And then the third year we launched it. So that's how we build it. So first year, working in silo, setting up architecture, kind of trying to follow our vision as much as possible, working mostly with one partner who put a lot of like knowledge and industry expertise in our process. And then essentially we invited other partners, and they all become actually our customers later on. And then the third year we launched the product. So it took a lot of time to build it.
Yeah, I mean, if you do it right, it takes a lot of time. But a couple of I would follow up on these. I've been also selling software to project developers, EPCs, etc. Everybody has a different workflow, right? So from the perspective of having universal software to be used by both EPCs, project developers, or whoever, I think your structure and building the product is very correct. But how did you tackle the issue of customer A or partner A wanting to bend the software to their specific needs? Because you need to find a golden middle ground, right?
Yeah. Yeah, that's a tough one. And as you know, the essence of any good strategy is choosing what not to do, right? And luckily for us, we actually have the full set of clients at the moment. We have APC contractors, we have manufacturers, we have developers, and we have engineering consultancies, and they all use our product, which is amazing. It's a huge, for me personally, it's a huge achievement. So the way it was done is that we picked very carefully things we want to build. If you think about the central topic of solar PV, I would say it's a kind of panels layout. All people, in one way or another, actually work around this topic. So if you think about someone who is responsible for making this layout, it actually can be electrical engineer, it can be civil engineer, it can be performance model engineer. It depends on the company type. However, their goal is still the same. They have different level of details, they have different level of inputs, but their deliverable is the same, essentially. So if you basically pick those kind of cornerstones and then you build your process around them, it will help you to invite as many professionals as possible in this process. However, it doesn't mean it's easy. It is very complicated, and luckily for us, we had enough resources and enough people to build like a true design modeling platform. And basically, but I would say the process, the answer to your question is that you basically find those cornerstones and you build a product around them, and you try to see how people work on them, what kind of insights they bring to the table, and how they can, like, you're trying to give them enough leverage and tools to actually to explore their insights and to explore their ideas. So that's kind of simple strategy we used when building this.
Clearly it did work, because I know that when you're talking to different stakeholders, of course, everybody has a different, to some extent, a different motivation, right? If you're talking to a project developer, you're talking to a sales guy, they just want to get the signature and then they kick the problem to the engineering team. And then good luck solving that. So if you can align all of those needs and motivations in a perfect workflow, then of course it's going to solve both the software problem, but at the same time, the project lifecycle and the project management problem as well,
Yeah.
right?
Yeah, but I also would say the first couple of years we actually were ignoring workflows. We were trying to build a system around the date, like layout as a layout seen as a central topic of the software. And you can do like things in many different ways. We actually inventing workflows right now only for the sake of people learning the tool faster. If you think about that, the people need workflows because it's going to be faster adoption for the tool. But in general, if you think about engineer, like a proper engineer, they have different workflows, even for every single project, depending on what data is available, what they want to optimize for, what like how much time they have, and all of that, right? So this is why, like, I would say that our first version of the product was completely, there was no workflows. And at the same time, there were like hundreds of workflows possible with the tool. We didn't limit, so the person didn't need to go through specific steps. Meaning, you can start with layout, then you can run cut fill analysis, that you can remove the areas where the gradient is extensive. Then you can go back to electrical blocking, then rerun gradient, then go to trenches, then go to medium voltage. So you could actually do it in any order you wanted. And
Okay, yeah, that's super flexible.
yeah, so we actually we invested so much time and resources in making it flexible.
Then it begs the question of how much does the person need to actually know about the software already to be able to go back and forth, right? Because if we are looking at most users would prefer to have a 90% done suggestion from the software and then start tweaking that and adjusting that. So what's your take on this?
I mean, that's a problem area, I would say. We The thing is that I would say that if you think about the one person who could actually understand more or less all the disciplines is some kind of design manager, but this person doesn't have enough depth of knowledge for every single discipline. So this person can run all the disciplines together only with a specific depth of knowledge, meaning that the solution will be
Level.
quite superficial. But then if you think about the other participants, they actually have a lot, like a huge depth in knowledge, but they cannot work with neighbor disciplines by themselves without attracting people. So that's the huge challenge. And obviously right now the most successful our users are those who have this curiosity to learn about other disciplines, or those who choose to isolate themselves. So we still don't see as much collaboration as we wanted to see, like really. Because if you think about engineers, they like working solo. Actually, all engineers like working solo. It's their managers who actually love collaboration,
Mm,
because
yeah,
they know that the solution to most of the problems they have is within collaboration, and it makes perfect sense. But this is the behavioral change, and this is a tough one. This is why we try. It's like you have, like, let's say when you have an innovative vision, but at the same time you want to get customers because you need money to deliver your innovative vision. So you try to find this balance where you actually allow people to do their job solo if they want, but also you have this option to do things collaboratively.
that's
That's hard to build, but that's definitely the answer. And if you think about AC software in general, there are so many people who actually talk about collaboration, but there was no collaboration during design software, during design phase. Wasn't actually solved by anyone,
Mhm.
except some easy cases. Let's say it's a feasibility tool and a couple of architects work together. This can be solved, but also it's not that they work together during feasibility phase. But then if
Mhm.
you think about architects, structural engineers, even like Revit, Tekla, Allplan, it's not solved yet properly. So it's like, it's a very hard problem to solve. And like, we don't see it in AAC still, which is really fun if you think about this in that way.
Yeah. I mean, it makes perfect sense. And you touched on a couple of topics prior. The most important that struck me is the learning part. You can have the best product in the world, but if you cannot translate the knowledge or relay that knowledge to your users, then that's a huge unmet need, I think, for most software on the market, right? So you want to be easy to use at the same time, but be able to allow the customers to dig in deep, as well as you mentioned before. So if I'm the project manager or the CTO of the project, I want to see everything from a high level view, but I want to be able to dig down deep in case I'm looking at the voltage drops, the cabling, etc., if needed. So how do you guys tackle this?
I will be honest, that's a great question. And I would say the way how I solve this easy to use thing is that I have actually my partner, Ben, who is working on this. I'm not the first person to work on easy to use. I would say I always choose functionality over easy to use. I'm an engineer myself, right? This is why the way I'm trying to solve this is by presenting to people tremendous value the platform can bring. And then those people, if it's a truly valuable for them, they will have enough spark to spend time and to learn it. So that's one approach, which is not the best. This is why Ben is mostly working on the making complicated software easy to use for people. I'm the one responsible for making
It's
solutions to
complicated.
complicated problems. Yeah, and then and then basically trying to convince people by showing a huge amount of value we create, and quite often it actually creates enough spark for people to learn it. But if you think about even like Civil 3D, learning Civil 3D from scratch, it's like 40 hours,
For
maybe
sure.
more. Yeah.
I mean, just
But if you think about go make easy to use Civil 3D. I mean, it's a very hard problem. And actually, typically the products that claim that they are easy to use, they don't do a shit. They just have like three commands and a little bit of functionality. It's easy to make them easy to use, right? Because they just don't have function. But now if you think about Civil 3D product, it's not easy to make it easy to use because it just has like thousands of commands and thousands of things. So that's the way I like to think about this, is that ideally you want, like, the strategy we have about making it easy to use is that we try to limit the people usage based on the amount of information they have and level of details they need. So if you think about developers, for example, this is our upstream users. They don't know how to make a tracker. So they don't know how to configure a proper tracker. Let's say whether it's Next Tracker or ATI or Nevadas or any other tracker provider. They just don't know that. And they don't care. For them, tracker is rectangle. And they just need to know how many rectangles you can fit on your site. So, right? But then if you start talking to structural engineer or civil engineer, then piles come into place. Exact lengths come into place. The
limits.
alignment around the motor come into place. So this is the level of details they need to do their job properly. Developers don't need this level of details at all. Like, they don't care. They basically assume that if they have the right rectangle, someone will manage details later, which is again the right approach. Because if you will need to gather all the details, all the information you need for the project to kick off, you will never be able to kick off any project. Yeah. So that's how we try to manage it. But again, I would say it's a tough one. I I would be extremely happy if at one day we will be able to say that we solved this problem. We're still
Time
in the
will
process.
come. You
Yeah.
guys are going in the right direction.
So
Maybe if we segue a little bit more into PV Farm itself, can
yeah.
we talk about the product? Who is the ideal buyer profile? What is the challenge that you are solving, and why is it perhaps better than the other tools on the market?
So the first thing I would say is that we created a product for utility scale, and we built this specific 3D engine for utility scale solar, and that's why it's quite well performing, meaning that you can design 1 gigawatt project without problems. So in our modern architecture allows doing this because we use for the modeling itself, for visualization, exploration, we use your local GPU, and then when it's like sophisticated calculations like cut fill analysis, piles optimization, and stuff like that, we run it in parallel on our servers. So this allows us to be basically more like better performing in terms of like size of the project and stuff like that. So the second aspect that I would mention is that it's a design modeling tool. It's so surprising, but there are so many tools in the market where you cannot edit layouts you make. It's so simple, but like there are so many products that making layouts that there is no way for people to edit. I think this is a huge problem, and that's what we had in mind from the very beginning. It's a design tool, meaning that you want to be able to actually to move any single tracker, any combiner box, any inverter, reblock it, rewire, and do it again and again non-stop without in a kind of non-destructive workflow. That's, I would say, the second advantage we have, which also, like all the tools, all our competitors that use AutoCAD as a base and their plugins, they all have it because AutoCAD can allow you doing this, right? However, there is not enough level of sophistication in terms of automation that we have. We, for example, in terms of optimizing layout and being flexible and using like multiple trackers, multiple inverters, sub areas, so you can design your site, you can break it down into 5 different areas, you can edit your roads, update layout, reblock it, use different inverters, use different modules in different areas, get the energy production for every single string on the site. And like basically like the level of details you can access if you want is tremendous, and that's one of our competitive advantages as well. And I would say these are three domains: so performance, and then editability or configurability, meaning that the software is extremely flexible. And so the third one is basically sophisticated automation, which basically together with the second point about flexibility create an option for different workflows. We usually say that we support three different types of workflows. The first one is advanced automation, where you just press a button, got something real quickly, really smart. So then we have a kind of fancy expert workflows. This work in an interesting way. So let's say you're making your layout, you're running cut fill, you define in the areas where the cut fill is the most expensive. You run in electrical wiring. You define in the areas where electrical cost balance of system is the most expensive. You map those areas and you see what's more expensive in this particular one. Is it moving dirt or connecting strings to the inverter? So you have this amazing option to do this kind of like a balance trade-off. As you can see, like the most efficient layout doesn't exist. It's all about balancing trade-offs. Like any
Yeah.
engineer understand it, right? So it's about balancing trade-off. What's more expensive for this particular block? Moving 1,000 cubic yards of dirt, or like moving additional couple of hundred cubic yards of medium voltage cable? So this is the type of questions that we can answer, and this is what we call fancy expert workflows. And then the third one type of workflows we support, we call it human craftsmanship. So if you have let's say a bunch of combiner groups, and you want to allocate a specific string or tracker from this combiner group to the right one, you can do it in PVFarm. You can move things, delete things, reconnect things, rearrange things, reblock things, and it's all possible to do manually, like in a proper design software like AutoCAD or Civil 3D. That's I think that people, it's kind of, when I say this, I always think, Max, it's so obvious. So obvious. Like, why do you even say that this is your advantage? But it is advantage because there are so many products that don't do that. Yeah.
Yeah, I mean, I agree, and I've done quite a lot of, studying and competitive analysis of all the design tools out on the market. And I personally also think that we are definitely moving to a more cloud-based solution system in the future sooner than later. Of course, CAD is always going to be here because people are used to it, but
Mhm.
it's more of, I would call it more of a necessary technical depth than anything else.
But you see, I didn't even mention that we are web-based software. I didn't
Yeah, but
even mention this because I don't count this as an advantage anymore.
I think it should be highlighted, because the typical setup um, for a typical design solution is usually by default anything CAD based, right? Especially when we are talking about utility scale. And then if you take one step further, of course, like you can be more flexible in cloud based because you don't need to push releases. You don't need to, any improvement you make, it's available instantly.
Yeah. But there are some other issues like people, like for example, if you think about like top EPC companies, they're so worried about their intellectual property. They're so worried about security concerns, right? And in that sense, we always have these conversations where I explain to people how our architecture works, like what kind of cloud securities practices we follow and stuff like that, right? So we even like think about this in a way. Whenever you upload your DXF file or KMZ file into PVFarm, we don't take it to the cloud. We basically read it on your local machine, convert it in our proprietary data format, and we move it to cloud. So because we were so, like people so many times, they ask the questions like, where do you store our files? And we're like, we don't want to store your files because it will create so much problems for us. We will need to explain, like we will need to delete them from time to time. So we basically changed the way we work with this simply because we wanted to support the concerns people have about cloud software. There are plenty of the concerns people have about cloud software, and but again, I agree with you. the future is in the cloud, and there are like plenty of different reasons. And I'm definitely happy that we're building a cloud software. But I'm just saying that sometimes it's just you need to, when you start like signing a huge contracts with the biggest companies, you start answering those security concerns questions, and it's fun. It's not fun at all.
Yeah, I mean, and of course, the data protection and all of these aspects helps you eliminate multiple objections as well, right? Because of course, all companies are concerned about their data, their designs, and if you say to them, okay, we are not actually storing them, or we are sealing them cryptographically, or whatever the case might be, that
Yeah.
eliminates that problem. So they can keep their data secure, and then you avoid,
Yes.
potential issues in the future.
Yeah. Exactly. Yeah. That's the point.
It's interesting to have these conversations, because I'm a sales guy by trade, so I used to hearing those issues and talking to engineers from a very different perspective, and it's good to kind of chew through all these issues and have a complete understanding.
Yeah. I would say yeah. Um, love filling security questionnaire forms. It's a joke and irony. I don't like it, but I know it's necessary, and that's why it's done. But
It is indeed, it is
yeah,
the necessary evil.
yeah, that's true.
But speaking of data protection, then I think and automation, I think the next logical segue would be to talk about AI. So, what's your
Okay.
take? How do you guys tackle AI, or what are the typical use cases that you see an EPC or a project developer being able to benefit from this?
I personally amazed by what's happening in the world, and I think it unlocks the whole new set of opportunities for all of us. My job became much easier, and I was able to move to the next level because of AI. So I love it. So I love this technology. However, I always try to be realistic about where it can help, where it cannot. As you can see, the most of the problems we're solving is a kind of built-in design generation problems, meaning that you need to generate some solutions automatically, right? And you build these solutions for engineers. And which means those needs to be deterministic, which means when I ask you to do certain stuff, when I ask software or algorithms to do certain stuff, I expect the same result again and again and again. That's the only way you can gain the trust from the engineers. That's where we don't see much value in current large language models, generative AI. It's not meant to be for that. So that's why like we don't use it for that purposes. However, what it's doing really well is actually writing code well, and it's actually orchestrating algorithms well. So we thought about use cases, and when we were analyzing where we want to use an AI, like, we wanted to avoid obvious things like everybody implemented a fucking chatbot in their apps. I'm like, what's the value of it? And especially when it's generic, not related to help center, not related to the product, it's like no value in it. So we when we were brainstorming how do we want to add AI in our tool, we were trying to do it in a most meaningful possible way. So essentially what we've done and what we thought, okay, so we have a sophisticated engineering tool, which has a high entry threshold. You need to invest a lot of hours to actually to be confident with PVFarm. So we actually tried to we connected. We played with many different large language models, fine tuned some of them, tried like RAG and augmenting, and like we did like a lot of experiments, and so we ended up having the assistant in the app that can help you to make your layout with a very limited knowledge. And what it means is that, let's say you're like, look, this is my site boundary. How much DC can I get? So this assistant can start asking you questions like, what inverters, what trackers you need to you want to use, and you're like, I don't know. Give me something. So give me something appropriate for this market as a starting point, and this assistant will make a layout for you. And then you can ask what's the difference in between ATI and Xtracker? And it will help you to understand it. Then you will ask, okay, what kind of benefits I will have of using this or that? What kind of workflow? So we kind of made an assistant that instead of like going and populating all of those parameters by yourself, it will translate your subtle, like your very superficial knowledge into kind of smart defaults. So we kind of that's our first step. So we are building this assistant that help users in the first place, upstream users that don't have this level of details to produce a meaningful layout. So that's our current goal. And obviously we call it a fallback plan. This will not like we already have it, and we will start our beta program in 1 month. So we'll start giving access to our trusted partners to this. But I'm already pretty happy how it's working. So I would probably even start it earlier. But then further, we actually want to move all our. We don't want our help center to be outside of the app. We want all the knowledge to be linked to the app, linked to the things you actually doing. And let's say if you're asking, like, imagine this question: you have a site that can fit 200 megawatts DC, but you need to get 150. And so the question you have: how do I chip away in the most meaningful way? And imagine that this assistant can actually lead you through this workflow. It can explain to you, first, let's find the most expensive cut-fill areas. Let's find the most expensive electrical BOS areas. Let's find the areas where does it make sense to increase the pitch in order to get more energy? Does it make sense to stick to a specific pitch, which is not the best, but shading doesn't eat so much? So it's kind of will help you to navigate through this process and by educating you. So it's kind of like yeah, it's like an assistant with a deep knowledge about how the platform operates and how the algorithm works. For example,
Yeah.
let's say the type of questions we get in from people, sometimes they are even, let's imagine you actually making layout and you specified a specific inverter loading ratio or the CAC ratio for every single block. And you made it as a hard constraint. So apparently you start making layout with some empty areas, which couldn't be filled because of your ILR constraint, right? So then the people have so many questions about why the algorithm is not doing this job. So this assistant is also is going to be explaining why is this happening. So what we're optimizing for, so we actually try to use it to build trust. We're not trying to use it to generate unpredictable results. So we're trying to use it as a useful assistant that helps people with limited knowledge and limited information to make layouts that make sense and to educate if necessary. So that's the kind of perspective we're looking into AI at the moment. Yeah.
I mean, it makes sense. And it also, we came back to the initial thought of the learning, right? So you have a great software that you want people to use. The most difficult thing is to get them to use it or get them to learn to use it, because otherwise they won't get the optimal results. So if this works well, then you can actually eliminate even the ease of use question, right? So you don't really need to be that user friendly. If this chatbot is that good, then you can pull the toggle the other direction a little bit, right? So to speak.
I mean, yeah, that's a big goal. I don't think we will be able to achieve this one completely with the large language models without sufficient retraining. We will try to do our best, and I think that's why we're using a combination. So first of all, we have a completely independent initiative trying to make product as easy to use as possible. And then we do this experiment with AI. It's still like kind of research for us, right? So in my experience, we've been building AI tools all the time we were existing, even starting in Creo. And I can tell that only less than 5% of experiments make it to production. Less than 5. Imagine this. Every 10 experiments you're doing with AI, it's a generative AI, neural networks, whatever. Basically 1 out of 20 will go to production. That's the level of research. And like obviously in the social media marketing, people talk a lot of bullshit, and the people pretend that we call it laboratory works, means that you basically made a specific case which doesn't really have like lots of value, but you actually pretend it as a huge opportunity. So it's a research in the first place, especially in the AEC industry at the moment. Yeah, this is the
Yeah,
areas we see AI useful for PVFarm. However, there are many more areas where AI useful for AEC in general, right?
for sure. I mean, I can see multiple use cases. For example, the how your project is generated. If there is a model that you can feed that you design 10 projects on hilly terrain, it should be able to recommend some, not make a decision, but make recommendation between option A and B, right? So then you will have a better understanding as a human, or you can be more simple and stupid yourself to be able to, you know, zoom on one option that's possible.
Yeah, yeah, yeah. That's a perfect use case. Yeah, and many more, especially related to built-in codes and all of that stuff. Even like imagine for EPC contractors, they have like hundreds of documents as their request for proposal. Basically, imagine they just have like lots of documents, and you need to start somewhere. In order to start somewhere, you need to extract key kind of parameters and key strategical points from those documents. Amazing use case. Basically, feed all of them to large language model, get your insights, generate the first layout, present it to client, discuss, improve further. Amazing use case. So as well, and it's meant for this. You know, it's done for this. Like we were testing like around 7 or 8 different language models. We actually picked Gemini at the end. Google doesn't do a good marketing, but their model is really great. Their model is really amazing.
I tried, I tested it for writing code, and you know, as a non-coder, it seems to be doing a pretty good job. You know, like you can build something simple.
I would say the Claude is the best for writing code. Uh, ChatGPT is the best for marketing and you know all of that stuff and some deep research.
Text based.
Yeah, but if you actually use something under the hood and you actually try to fine tune something and try to give as much context as possible, in our experience, Gemini was the best for our task. So, and then we started playing with how to build this knowledge base. Is it enough context? Do we do RAG? Do we do fine tuning? What do we do? Fine tuning is expensive. We don't want to invest that much money. You know, like but it's amazing, man. It's like, I'm so excited to be living this time. I mean, you know, sometimes when you watch those younger kind of generation making those tools, you can see that there are some like I would say obvious problems. Right now, it's easy to build tools, but it's not easy to find the actual use case for building tools. So like finding the business case is actually become extremely more complicated because of a lot of noise and, you know, you
Yeah.
need to have deep knowledge to do that. But actually making tools is easier. But because the business finding the good business case is harder, it's balanced out. It's kind of the same.
Yeah, you end up in the same situation.
Yeah, you end up in the same situation, and I'm thinking, is it like me getting older and speaking this from a perspective of you know a little bit of like pessimistic person in a way? But I don't think so. I think it's the way it works. You got a huge advantage in one place, and you just you know it's still not easier to build a successful product, especially if you're speaking about AEC industry. But I love this industry.
Yeah, I mean, it makes sense. On one hand, I think it's going to be leapfrogging, right? So if we make some progress on the technical side, then you will need to catch up with the business and the solution side of things. And it's going to be going like this. The biggest problem is you have the hype on all levels, right? Anything AI is sexy today, which probably it's like the dot-com boom, and I think it's going to burst quite soon. But we shall see in the future. But speaking of that, maybe let's segue a little bit more into the entrepreneurship side of things. So what inspires you? Why did you start Sunbeam? Why are you in solar? What is the main motivation behind that?
Well, I'm really an engineer. Love uh, solving complicated kind of engineering design problems. This is just like, you know, even when I didn't earn money, I was doing this in my free time. So like when I was building those plugins and all of that, I was doing it for the pure joy of doing this. Right. So I think that's the first aspect of it. And I'm like, right now I need to do a lot of stuff that I don't enjoy as much as just building, you know, like I'm a sales, I'm a marketing, I'm a customer success and all of that. And there are some things that less fun than others.
But
But yeah,
doesn't it give you more perspective on the product of how
it does
people
give
are
me more
actually using it?
perspective. It does give me much more perspective, but I would lie if I say that I enjoy equally all of that.
Yeah, of course. It's a necessary evil, right? If you're running a company, you need to speak to the customers as well.
You need to do all of that. You need to do marketing, you need to do sales, you need to close contracts. I don't think that any founder that started a company should hire any salesperson until they didn't sell like first 10, 15 licenses. So like
For sure.
you absolutely should do all of that. But I would say that the starting spark and everything, like I really like this sophisticated problems, and I have this dream to build a proper, like a vertically integrated tool. And I remember I was inspired even as a student. There was I think it was a series from it's called Mega Structures. It's basically a set of videos, so a set of like kind of movies about how the like greatest buildings were built in the world. So it's
On
about
National
Howard.
Geographic or
Yeah, it's National Geographic, exactly. So it's about Hoover Dam, it's about solar farms, solar different types of farms. It's about Burj Khalifa in Emirates and all of that. So I remember I was really enjoying watching those, and I remember that I was dreaming about being able to be involved in those projects during design phase or during construction phase. I would say I like the design phase because of this kind of digital world, endless opportunities, computational things. So I really, it just feels right. It just feels amazing. It's like you're doing something and it feels amazing. So that's why I stuck in that place in a way. But also like building a proper like a vertical integration. I think this is the right way to actually build better buildings in general. I believe in I believe in a vertical integration. I don't believe in decentralization. I think it works well for certain areas, but in general, if you think about, and again, Tesla might be not the best example, and there are many companies like, or like many tools. It's really inspiring how the source system started. That they started from a company and they build an internal tool, and then they basically make it commercial, and then the commercial part of it has become bigger than the company itself. It's an amazing story. But I think like my personal passion is to build like the only way you can build buildings. I'm calling it building, but it doesn't need to be buildings or infrastructure is by simply becoming a vertically integrated company. Like for example, you cannot design your solar PV farm in Revit. Just cannot handle it. It doesn't. It wasn't created for that. Or like you can do the huge set variety of things in Rhino, from jewelry to cars to buildings. But it's just, again, it's not meant for actually building a perfect or designing perfect solar farm. So this is why I believe like every specific type of building object should have a vertically integrated tool that will help to design it in the best possible way, using as much as possible construction knowledge, logistics knowledge, staging knowledge, pre-construction, procurement, all of this connected to the real market. What can you sell? What can you buy? Where you can find those objects? Can you bring your panels from China? Can you buy them locally? Like all of those things. That's why that what makes like a vertically integrated tools, I think, extremely powerful.
it makes sense on an idea level, but let's run with the panel example, right? It would be perfect to have, an API connected to all panel manufacturers. You would pull in all the data of the dimensions, the wind loads, etc., into your software. But here's the but: we are working in two different softwares, right? So in order for us to make that happen, we would need to connect an infinitely connected workflow or software package where everybody would need to open up their APIs a little bit just so to get the benefit out of it. What's your take on that, just to play the devil's advocate?
Yeah, but if you think about this, you don't actually need API to all the solar panel manufacturers. You need to be able to basically to know what's in the market. It's not that you can buy any solar panel from anywhere in the world if you're in the United States. There are tariffs, there are many limitations. I mean, if you think about like a market trends, and this is part of why it's fun to build software, because you start kind of understanding the market trends. For example, solar panels in Europe much cheaper. And the reason they are much cheaper because you can buy them from China. And because of that, you use fixed tilt, because you don't need to. It's like when your panel is expensive, it kind of says to you, you need to squeeze as much as possible from this panel because it is expensive. So how to squeeze as much as possible from this panel? Single axis tracking system. So you kind of justify the expensiveness of this panel. In Europe, you don't need to do that. They're cheap. let's put a fixed tilt system. So then you can see that Europe is about fixed tilt, US is about SAT, mostly single axis tracking system. And it's like, and then tariffs and all of that. And then a tax credit. How do you get tax credit? Do you get it on the whole layout? Do you get it on the part of the layout? And like, you kind of need to analyze those macro trends as well. And when you build in software, you need to take it into account. But the vertical integration is not about having access to all of the panels. It's more about kind of linking design phase with construction and as much as possible, and also restricting your design phase by construction, because like anything can be built, but only things that make sense to build will be built, right? So it's
Yeah.
like technically you can build like a 5 stories parking garage and place like million panels on top of that and like make the full skyscraper of solar panels. But does it make any sense? No, it doesn't. So it
Yeah.
doesn't make any sense because the projects, it's, if you think about how the projects are, the only projects that are being built, those that are financially viable or those that people have money for. Like if you have
Yeah.
money to build a useless project, you can do that if you can afford this, like, but in the reality, it's all start from money. And it's like people, this is actually a fun story that people think that the places with a lot of sun should have a lot of solar farms. This is ridiculous. Because if you think about this, it's actually the reason people build solar farms. It's a tax credit. It's not, it has nothing to do with sun. And also if you think about solar panel itself, it works the best where you have a lot of sun, but also lowest possible temperature. It doesn't work well on the equator. So it's like, this is the most popular and fun myth I'm dealing with, especially when you explain to your friends and your relatives about what you do. All the people think that you need to build solar farms where, in the places where a lot of sun.
Yeah, it's actually quite. I had a customer in Finland and they were only installing solar on the side of buildings because they have a perfect 90-degree angle closer to
Yeah.
the Arctic
Yeah.
Circle. So, yeah, and they get quite a bit of sun. You don't need to clean the snow, etc., etc. But that's more the practical aspects. But you mentioned money a moment ago, and I think everything in solar, just like in any other business, boils down to money, right? How
Yeah.
much am I going to invest? And what is going to be the yield or the production of that solar plant
Yeah.
that I'm going to get out of it. And based on that, as you mentioned, if I know how much am I going to produce, all of my decisions are kind of cascading back from there, right? As you mentioned, the trackers or the fixed tilt systems, etc. So that's also an interesting angle to look at things.
Yeah, exactly. And I would say it's even, if you think about it, even like if you do like 10 steps back, obviously there is a very important part where certain countries make a decision to support renewables, right? I don't, this is very important. And then tax credits and all of that. So then people, hey, like, okay, what amount of energy can I produce here? And then the next question, what kind of PPA I can set up with the utility company? How can I sell this energy, right? So people optimize for PPAs as well as for money. Then what kind of loan can I get from the bank to build it? How long would it take to build it? I think these are like 4 questions you start in your spreadsheet. And usually it's like just a simple table where you can actually start making those things. And then this is why it's extremely important to actually to see all the risks early in the process, right? So if you, let's say if you, for some reason, just placed the panels and thought that you can make 200 megawatt DC, but at the end of the day, 20 out of that 200 is a very expensive. So you need to pay a lot of money to install it. And then the value of energy that you will sell later on in the process will decrease because of that, because you will get less money back. And this is amazing. Again, another amazing engineering problem is that find this sweet spot. And like, because some people make money by selling to utilities. They just sell it in the times. It's like selling like your stocks and shares and securities, right? So you're selling them when they are expensive, and you're buying them when they are cheap. That's why battery storage comes in place, which is again game changer. I think battery storage is a game changer for the future. So we'll
For
see.
sure. And I mean, from what I've been hearing, especially in the last 12 to 18 months, is that 2025 is really going to be the year of storage. And I think it makes perfect sense from a perspective of until now, if you're, especially if you talk to an APC, etc., they were focusing on building their power plant most efficiently, etc., as you mentioned. But I still feel the issue of being siloed. So we are not delivering end-to-end energy systems, but we are delivering, a solar power plant. Okay, here are your panels. It's going to produce something, but then you do whatever with it. Taking your example, I think we should think a little bit beyond that and think about the next step will be, of course, storage, then selling it back to the grid, selling it back to the operator. What is the grid like? Then we end up with something like in Portugal and Spain, and then everybody is
Yeah.
blaming renewables. And I think the bottom line is if we build an end-to-end system, it's going to work, and we will transition into carbon neutral economy very quickly.
Yeah. And that's, you see exactly what you mentioned, the Silas. It's just on the next level, right? And I think that actually the only way to, this is why I like this companies, IPPs, independent power producers, because they are actually in control of many things. And when you have like one entity that can control the process from the beginning to the end, you have a better chances of actually reduce the noise from silos. Because if you have too many entities, each one of those entities, they basically pursue their own goals, and there is no like a common narrative or vision or common like goal in general, and that's why it gets actually siloed. So, and then when you have many entities siloed, then that's where the problem begins. And that's why we actually, if you think about the problem statement I mentioned in the beginning, that we started PVFarm with trying to unlock this collaboration, to unlock those silos. So the people can follow what the owner, the person who actually invests money in solar, is pursuing instead of like their own siloed goals. So it's actually funny. I it's yeah, that's why I believe in vertical integration. It's just I cannot even like, I always think about decentralization and all of that, but I cannot believe this will make a great. That's why I believe in the companies that do a lot of things in the house. Like even I like EPC type of company because they do engineering, procurement, construction. Because they build it. They don't want to engineer it badly because they're gonna build it.
Yeah.
It's like a skin in the game. So that's it's just it's more like a philosophical kind of argument about it.
But it makes sense. And I mean, again, if you have a system where all the incentives are aligned, as you mentioned, if you have skin in the game, and if you are going to build a badly designed power plant, you will think twice about, selling it and,
Yes.
and getting into trouble with that. So it makes perfect sense. And I mean, if we zoom out, hopefully we will end up in a system that's more interconnected, more efficient, eliminating the barriers we mentioned. And then hopefully our children will live in a better world for sure.
So yeah.
We are actually coming to the end of our time, but I have two quick questions for you before we wrap up. If you had one ask for the audience, what would Maxim be looking for? Would that be, what are you looking for? Are you looking for knowledge, people? What would it be?
I would say if those are people related to PV design, so I would definitely be looking for insights. We do a lot of posts. We do a lot of like educational content. We have a design debates topics. So I would definitely invite people to talk more about things and to discuss the problems we have in the industry. Because I think this is where we actually need to stop being silent and need to talk more and discuss things. And that's the good basement for a great products to occur in the future. So that's more collaboration. Yeah, more collaboration they ask from the audience. In general, if there are people that not related to solar PV, we still think about interesting problems in the market. We looked into data centers, and we looked into other types of buildings. And if someone has an interesting problem to solve, reach out. We'll discuss how it is possible. Or even if someone needs an advice, someone who never built a product and the people want to build a product, always happy to share what we've learned through our journey. So I'm happy to give as well.
Yeah, for sure.
Reach out. will be happy.
So on that note, we will actually link to all of those in the show notes below. But what would be the most efficient way to reach you?
It's basically so you can find me in LinkedIn, Maksim Markevich, or Maksim at PVFarm.io, or Maksim at Sunbim.io. Two different emails I use, so any of those would
Perfect.
work.
I'll put that in the show notes as well.
Yeah.
Perfect. Maxim, thank you very much for sharing your knowledge. It was a really interesting discussion. I hope to speak to you soon, and take care.
Thanks, Peter. Good luck. Good luck.
Cheers.
We'll be in touch. Bye bye.
Bye.